Okay, I'm going to attempt to make a video about the assembly of the double stack candle here. And that's not going to be easy because this place is a mess. I mean, it's kind of a contrived facility. Excuse the background noise, that's the printer running there. Printing yet another product idea out. But I'll try to, I don't know how useful this will be to you, but I'll try to take you through some of the basics here. And but I don't know how visible it's going to be because this is such a crowded bench, and I was really reluctant to even make this video because it's just such a pain in the butt to, to do it in this kind of a crowded situation. But I'll try to explain what I can. Maybe it'll be useful. I don't know. Like I said, I wish I could do this in my lab, but it's just so much more efficient to work where I live because, I mean, I can work way more hours this way practically than having to go over there every now and so many hours a day. It just doesn't work as efficiently. It did before the fire, when I used to live over there, then that was great. But this is an ESD strap, by the way, if you're working with LEDs, which I will be. I just have it strapped to that. My power supply, which is grounded. I also have an ESD mat here, which is nice to have. And this ESD strap, I bought at Jamico for, like $4. They carry them on Amazon too. And then the ESD mat the same way. I bought that at Jamico, I think, for about $11 or $12. They're not too expensive. But, when you're working with LEDs, particularly any color other than red, it's a good idea to have an ESD strap because it will damage the LEDs. Believe me, it will too. They're very static sensitive. You just strap it on like that. It's pretty damn annoying, but it gets the job done. It's my soldering iron. This is not a variable temp station like I got in the lab, but it gets the job done. This is a really good one that I actually got for free when I was buying some equipment a long time ago. But again, you can pick up soldering stations at probably on Amazon, but definitely like MCM, places like that for $60 or so that are variable temp and everything, digital readouts. Or just go with a pencil iron, if you want to go the cheaper route. Buy a Weller or something like that. I don't know. Anyway, see, that's the problem. I can't even see the screen on this thing. I'd have to put it here, which is where my work light is, and I don't know that I'm really going to complete this video because of these problems. I just don't know where, I'm going to be knocking this camera over all the time because of these wires. I just really don't think it's that practical to do it. But, I've already, soldered some of the components on here, the switch and the power adapter and, the slide switches. So, you can see what I did with that. The circuit board didn't really come out that good. I over-routed it, so I was going to make a video about that, with a Roland, but, honestly, how many of you have a Roland? So, I really just decided not to mess with it. So, but at any rate, that's that circuit board, and here's the display board right here, and so I'm going to solder the LEDs to that. At any rate, I'll set it up. I'll set it up here, and I don't know if this is going to work really. Distance on it. Like I said, I know I'm going to be knocking this thing over all the time. Not much I can do about it, really. But I guess that's pretty good. Recording. Okay, now, like I said, we got resistor values, you know, if you remember from the schematics, if you want to reference that. How I'm going to arrange this, remember this kind of mounts, you know, like that. So I'm going to arrange it to where this is our lowest setting on the left to our highest setting across to the right. So that's how I'm going to do the switches. So what that means is that I need our highest resistor values on this side working to our lowest resistor values on that side of the circuit board. And of course this switch gets its own force, because this switch, push button, if you recall, powers our outer ring of LEDs. In fact, I'll go ahead and start by just soldering the LEDs themselves to get that over with. Let's see, I gotta find them first. That's probably not these. That's my wide angle lamps. This is such a mess that, you know, I'm trying to do a lot in a very compact area. It really sucks. Now that's my UV LEDs. See this? Yeah, these are them. Okay, so I need 6 of them. 1, 2, 3, 4, 5, and 6. Set those aside. We'll go ahead and stuff these LEDs in the circuit board. Let's see. It's kind of arbitrary which way I put them in this case, but the center area here is the common. So, you know, in that case, in this case, it's the ground wire. So, therefore, you know, when you're looking at LEDs, this longer lead is the anode, and the shorter lead is the cathode. And also a little trick in LEDs, I don't know if I can show you this or not, you'll see it on the camera. But if you look very closely at the LED, and even the flower mode, that's not really showing up, but you can notice that if you look at the lead frame inside there, the metal part inside the LED, it's usually, I've only seen one LED where this isn't the case, and it was a red one by Cree. But usually the one with the heavy, you know, you'll see that one of them is skinny. You know, one part of the lead frame is skinny, and then one is very thick and heavy. It's usually the very thick and heavy lead frame that's actually the cathode. It's almost always attached to the cathode. So, you know, if you can kind of see there, you know, which is the cathode and which is the anode. The anode's the long one. So, like I said, you know, you'll notice that there's a short, skinny stump in there that's attached to the anode, and the cathode, you know, is the long, heavy one. Now, the other ramification to that is that what that usually means is the long, heavy, the big, heavy stump that you see as part of the lead frame, you know, is actually the thermal stump. In other words, this little skinny one, there's actually a cast whisker, a little tiny, tiny wire that actually jumps from that skinny post to the top of the LED and the more thick post. Now, that means, you know, if heat's trying to escape from the LED, it's not much of it's going to go through the little skinny ass wire out through the anode. It's almost all going to be conducted through this heavy die mount, you know, it's in the lead frame, and it'll be conducted out through the cathode. And again, with the exception of that one red LED, every LED I've ever seen works that way. So, you know, when you're designing around LED circuits, just remember, almost all the heat's going to come out of the cathode lead, not the anode lead. So when you're actually trying to make a beefy, you know, pad below it, you know, to dissipate heat, you know, always make sure you really pay particular attention to the cathode, because that's where almost all your heat's going to come from. Very little, if any, is going to come out of the anode. So, you know, and heat kills LEDs, so, you know, you got to be careful about that. Anyway, having said that, like I said, we've established, you know, where our ground is here, and that means these two pads, well, let me put it Um, these two pads are the anodes. That's for the outer ring, that's for the inner ring. And this is the cathode. So that means our cathode has to, connect like that. So I'm going to go ahead and start stuffing the LEDs with that in mind. Oops, I got it backwards. Okay, so I got the cathode on that row, or that ring, hooked to that, and cathode to that ring, running this outer ring, running to it too. So, and I'll just continue to populate the board with that in mind. Okay, so it's got all 6 of them stuffed in there. Now I'm just going to simply move this stuff out of the way. Over here, I don't know if, let's see if this is going to be in the shot. These pliers and stuff out of the way. But I'll just flip them upside down. Okay, get my magnifier in position because I can't see crap without them. Okay, kind of see what's going on here. Okay. Like I said, this isn't going to be very visible, but again, you're lucky I'm doing anything at all because this is kind of a pain in the butt through this video. So you won't be able to see what I'm really doing, but on most of this stuff, but you can kind of see it from afar. And like I said, I wish I could get a close-up shot on this and show you how I solder circuit boards. But what I typically do, I'll try to describe it for you anyway, is I'll hold the iron, I'll actually touch the iron right up next to it, to the lead that's poking through the circuit board, and so it contacts the lead and the circuit board itself, so it heats both up at the same time. And then in the gap between the two components, you actually feed the solder into that gap, right into it. I usually approach the LED, the lead side of soldering. Sometimes you need to kind of smear it, and what you're looking for is for the solder to flow. Which is a sign that's wetting the copper. So you can kind of see a little bit what I'm saying, how it's formed a, it's actually spread out and wetted the copper. You don't want to beat it up. Now that's why we do your own circuit boards. Make sure you hit them with some Scotch-Brite or steel wool, something to clean them off and brighten them, otherwise they won't solder worth the hell. So finish this up real quick. Anyway, it just takes a little practice, but once you realize what you're looking for, you're just looking for solder to, wet the board and start to flow out on the circuit board, and make sure that it's also contacting the LED, that you don't have things, what they call a dry joint, which is where solder is on your, typically where solder is on your circuit board, but not on your lead, your component lead. That's definitely what you're trying to avoid in soldering. So, but again, it doesn't take a lot of, practice, but it does certainly take some practice to get the hang of. And that's what I got. Now you get another thing to buy, and I always buy these little cheap clippers, these Z-Lite. Damn it. Little clippers like this from Z-Lite is usually about $4 or $5, for a pair of these, but you know, it'll last as long as the $50 clippers. But honestly, you know, if you don't use them a lot, and even if you do use them a lot, we use these in production all the time because it was cheaper to actually buy lots of these, you know, when they wear out, you know, than buying the expensive ones, which wear out too, just not as fast. So, you know, from a production standpoint, it's usually cheaper. Anyway, it's got the LEDs done. Now let's see if they fit like they're supposed to. Yep, right in there. And it looks like they're flushed up properly. So let's see if they actually do fit. Yeah, so it fits quite well. You know, see, there's no gap on the housing, so you know, standoffs and so forth are right length, so that works. So, so that's got that done. Now, let's see. I don't know what I do with all the parts. I gotta find the relay. I forgot what I did with the relay. I'll lay it over here somewhere. But we'll get back to that in a little bit. It's not important right now. Okay. Still on fire. Man, I'm just about 2 seconds away from stopping this video. Let's see. Okay, so like I said, we're gonna work our way from left to right. You know, the biggest values going to smallest values. Let's go ahead and take care of this switch here first. Now I need a 100K resistor, because I've changed that 39K on the schematics to 100K because, believe it or not, that's still too bright. You know, one of my LED flashlights I used a 39K and it's still too bright. So I'm gonna try to go to a much higher value resistance in hopes of reducing its brightness much further. Let's see. These little resistor kits too, by the way, I bought it. There we go, 100K. You know, I bought it at Jamico as well. They have some pretty good values on a lot of components. Not everything, but pretty good. Okay, so that's one 100K resistor. I'm going to take that out there and put it into one of our slots. This video is probably going to bore most people. Okay. I'll probably put it in the... It really doesn't matter which slot I put it into. It just matters that it's a different one in a different slot. Filthy, it's hard to see where it goes. Yeah, that's where it goes. Okay, next I need to find, you know, something along the lines of 150K. I mean 150 ohms rather. And here's 156 ohms. Just kind of wrote these values. Now see, these resistors are too small for me to make out the color bands, so I really can't read them. So I have to go check them with a meter. They're just too small. I just can't see them even for a magnifying glass. Can't be sure what color I'm looking at, or, you know, it's 154 ohms. Okay, so I need 2 of those 154 ohm resistors, but I do need to check this before I commit to it, because again, those are theoretical values, so I want to test at least 1 or 2 of them. So I'm going to set my power supply over here to 12 volts exactly. You know, that's what I've done. Now you can buy these power supplies off of Amazon for, I don't know, not a bad price. Let's see. Yeah. Like I said, I set it at 12 volts exactly, so I'm going to go in and check the current. Oh, piece of crap. I'm going to check the current. Nice thing about this power supply, what I really like about it, it's got a built-in DC ammeter, so you know, it makes it a lot easier to test things like this. Let's see. Need some alligator clips. I got these cheesy, cheap-ass, hardly works alligator clips I bought off Amazon. Some Chinese. They really suck. Let me put the ground lead from the power supply for that. Put the anode lead, positive lead, up to 150 ohm resistors. Okay. And then okay, that's about 19-20 milliamps, exactly what I want. So it's a perfect resistor value for it. So, you know, they work just great. And those rings work, so perfecto. These alligator clips aside there. Okay. So I need 2 of these 156 ohm resistors. Remember, we got 2 circuits. You know, one of these goes to the outer ring, and the other goes to the inner ring. So this first one I'll put right next to the 100K resistor I just put in there in the appropriate position. First one, oh, no, I went the wrong direction with it. On the wrong side. Man, I hate making circuit boards this way. I much prefer to work with actual circuit boards from the vendor. It's just, you know, if you're on the budget and you got the equipment, that's the way to do it. Okay, it's got those 2 in there. Now let me see if I can find the other one. Okay, like I said, we're working from this way to that way. So this 150 ohm value is the smallest value I have. So the central trace down here is actually our bus. You know, that's where all the resistors tie in for the inner ring of LEDs. But this is going to be the rightmost switch position right here. So that's going to jump her over to that bus with this resistor. So that's what I'm going to do right now. Just put that in there. If I can find the right holes. Since they're not marked. Alright. Works perfectly. Okay. So it's our 150 ohm resistor. The next on the list is something along the lines of 330. So I doubt that I have something like that lying out here just freely, because these are all 8th watt resistors. Again, if you recall, I had to use the smallest one possible. So let me dump these out real quick. And again, I'm just going to go with stock values from now on. So let me just go ahead and locate all of them. So I'm looking for 330, 680, 1.4K, which this only goes up either between 100 and 1K. So I'll try to find the 330s and the, let's see, here's 390. That'll probably work. You know, when you're sizing resistors, you know, usually a bigger, slightly bigger value you'll be okay with. You know, it's not going to likely burn your circuit out or anything because of a bigger value resistor. But smaller, you know, you're taking a chance. It's always best to test if you're thinking of, you know, using a smaller value. Okay, so yeah, I might need to test some of these. Some 270s, but it looks like 390, or well, here's some 330s. Again, I'll have to test that, and I'm looking for 5 or 680. It's 550, which might be acceptable. It's a little smaller, but again, when we get to the bigger value resistors, they're all underdriving the circuit anyway, so it's no big deal. In this case, let's see, here's a 680, and there's one left. So I'll go with 680. It's actually exactly what I said I needed on the list. Okay, so that's all I need for the sub 1K values. Put these all away. Then I need, look for the 1K to 50K range, which I'm going to need 1.4, 3.2. Dump these all out. 1.4, 3.2, and 12. Okay. But I took the time to go mark these. It's 3.8K. 1.2K. So it might be a substitute for 1.4. Now here's 12K. Okay, here's 3.2K. What I needed. $1.5K, which is another alternative. $2.8. Again, 3.2K. Okay, so let me light up my meter here and verify these. way, 680 ohms. So that's 680. Like I wrote down on it, since I had to write them all down. Yeah, it is. So that's good. 330. Yep, 339. That's good. Okay, the next one was 1.4K. The closest I can really come to it, I'm going to err on the side of being larger, is 1.5K. So instead of 1.4K, it's 1.519. So I'll go ahead and go with 1.5K instead of 1.2. Now 3.2. Which it is. 3.28. I'll go with that. So I don't need that one. I don't need that one. Don't need that one. Don't need that one. So the last one is a 12K. Yeah, 11.9, 1.8. Close enough. Okay, so I'm going to get this meter out of my way. Of course, there is one more value I might need to check. We'll get to that in a little bit. Okay, but let me continue what I was doing then, the stuff in these resistors. Okay, so the next biggest value I need is 380 ohms, which is our 330 ohms. So I'll put these in, or this in. So okay. Put that in. The next biggest value is the 680. It's only one of. So the next available slot, which right there. On the 1.5K. Then 3.3K, 3.2K. And finally 12K. So I'm going to do a current measurement when I'm done with this, so I can find out what the actual current, because remember these are all theoretical. But again, I'm just going to let the chips fall where they may on it instead of making a complicated headache out of it. but I'll need to measure the current for each and every one of these settings just to see if, and write them down so I can make my battery longevity chart. So, anyway, it's got all the resistors populated, so I just got to go solder that. Let's see. I wouldn't use my helping hand just keeping this stupid cheesy ass light up. I'll just solder it the hard way. Okay, let me take care of these for a minute. Traces again. I routed this when I routed this circuit board. I put the router too deep, and it really took a big kerf out of that. The traces here, so some of these have to actually bend over because they're actually halfway routed through the hole. Sure, this video is going to be awesome to you since you're sitting there listening to printer noises the whole time while I'm numbing.